Hello, Professor Sash here. I'm going to be talking about orbits and rotations. And we're going to be using this little section of the parking lot, sort of that's kind of mostly circular, to help you get a grasp of how planetary motions affect the experience you have on this planet. So we're going to start with a couple simplifying assumptions, and I'll give you a quick breakdown of the limits of those. We're going to start by saying we're going to be moving around the parking lot in this direction, orbiting its center. We're also going to be rotating in the direction we are orbiting. Most planets, due to the conservation of momentum, tend to rotate in the same direction that they are revolving around the sun. So you notice I am revolving counterclockwise around here. This is definitely a little bit northern hemisphere eccentric. And that's just how it's going to be. And I'm also rotating counterclockwise, very slowly here. The few planets that do not do this, that rotate opposite the direction of revolution, are known as having retrograde rotations. Now, it's more common to see retrograde rotations than it is to see retrograde orbits, because it's sort of like driving opposite the direction of traffic on the highway. You're likely to crash into something, and when you crash into something, it gets to be a hot mess. We saw that with the spandex demo. So I want you now to take a close look as we sort of slowly rotate. Now I'm going to do one full rotation. I want you to note the position of that beautiful, what looks like some schist in front of me, as I do one complete 360-degree rotation while revolving. Do you notice that having completed one 360-degree rotation while revolving at the same time, I am no longer facing that boulder? This is what is called a sidereal day. I'll place a little image of this on our monitor. Sidereal days are about 23 hours and 45 minutes on our planet. And that extra little bit of rotation requires that I'm facing basically back towards the same direction, towards the center, towards the sun. That is called a synodic day. That is going to take, that little extra rotation is what gives you your 24 hours in a day. So what you're seeing is that every time the sun rises and sets on a planet undergoing rotation in the same direction as its orbit, you're actually seeing a greater than 360-degree rotation of the Earth in every one of these. Likewise, the moon's orbit has to actually orbit Earth, has both a synodic orbit and a sidereal orbit, and the sidereal orbit is going to be about 28 days, whereas the sidereal orbit, the time it takes to get back to the same approximate position in the sky with respect to the sun, is going to be just a little bit longer. There's a couple other things you might notice about this orbit now that I'm doing this. You might notice that I've gone up a hill and down a hill. This is sort of just the limits of what I could do in the time I had here. In case you're wondering why I'm at this parking lot, side note, I'm just sort of chilling with my mom. We're doing lake host duty. Mom's doing most of the work on that, helping to stop the spread of invasive species in freshwater lakes in New Hampshire. So, right. But you notice also that there's a little bit of a hill here, and that my sort of orbital path, even if it was a perfect circle, which I guarantee you it's not, would have a bit of a tilt. And we do find that all orbits have some degree of inclination. The moon's orbit around the Earth has a considerable amount of this. If the orbit of the Earth and the moon were always and was in the same plane as the orbit of the Earth around the sun, the Earth would pass directly between the Earth and the sun on a regular basis. Gonna have to cheat here. It's a bit of a creek that I don't want to get my too muddy crossing. And so as a result, there's only 2 times a year when the moon passes directly between the Earth and the sun, and only twice a year does the Earth find itself directly between the moon and the sun. We call each of these events eclipses. And I'll be showing a couple more images of these in the next couple of slides. Some actually from earlier in this summer.